Hello everyone. Hmm. This video, I'm going to show you the. Okay, let's go to the new sections called elastic collision or collision. Okay. hmm And first of all, we introduce the elastic collision, and then we go to the inelastic collision. And for the elastic collision, okay, here is the. Let's just right now just introduce the one-dimensional elastic collision. Okay, the one-dimensional elastic collision. Okay, let's make life easier. Okay, okay. Wow, sorry. Hmm. Okay, here is a setup for 1D collision and 1D elastic collision. Suppose we have two object M1 and M2 and doing the motion in horizontal direction. Yeah, 1D collision. We just assume everything moves in a horizontal direction and no move motion in a y direction or z direction. And M1 carry a velocity V1, M2 carry a velocity V2, and then suppose whether no matter what, suppose and they collide to each other. And after the collision, what's the velocity of M1 and what's the velocity of M2? Okay, and the velocity after collision, I use the prime. I use the notation prime. Okay, the prime means the velocity after the collision. Yeah, it's very similar to derivative, first order derivative, but yeah, but I cannot find another better notation. So just allow me to use the prime. Okay, prime to do the notation. Okay, prime, v1 prime, v2 prime. So our goal is, okay, what's the v1 prime, v2 prime? And what's the velocity of these two objects after the elastic collision? And how to solve this problem? We'll use two concepts to solve this problem. Okay, first of all, during the whole collision process, the system is isolated. No external force. System is isolated. Okay, first of all, system is isolated. Okay, isolated system. Isolated system. An isolated system, what this tell you? An isolated system, momentum always conserved. Momentum conservation. Momentum conservation. Okay. And okay. And what else? And for the okay for elastic collision. Okay, what that should I address? Uh, actually, mechanical energy isolated. No external force. Hmm. Okay, let's introduce this first. Okay. And I say this is elastic collision, okay? Elastic collision. So, of course, there's another type of collision called inelastic collision. Inelastic collision. Inelastic collision. And the difference between the elastic and inelastic collision is in elastic collision, the kinetic energy, no kinetic energy loss. No kinetic energy loss. Okay. That's called elastic collision. But for the inelastic collision, that means you have kinetic energy loss. Okay. So since it's elastic collision, so we can have this one kinetic energy, kinetic kinetic energy conservation. Okay. So, and some would say, is that the energy, isn't that should be energy conservation? Okay. That's what we introduced delta K plus delta U equal to 0. Okay. And but in this 1D elastic coordination in this setup, okay, because we all moving in the horizontal direction, so there's no height change. So the potential energy change is 0, and also the system, there's no spring, no elastic potential energy in this system. So there's no spring potential energy or elastic potential energy, and there is no gravitational potential energy. So this is okay. So this is all overall is 0. So so we will have delta K equal to 0. Okay, so that's why, and also it's in elastic collision, so the kinetic energy conservation. Okay, so I just erase this. Mm. Okay, so we will use the momentum conservation and in kinetic energy conservation to solve the V1 prime and V2 prime. Okay, let's get a start. Okay, let's get a start. Let's get a start. So first of all, momentum conservation. Momentum, do you remember that? Momentum conservation. Do you remember momentum is mass times velocity? That's momentum. Kinetic energy is 1/2 times mass times velocity squared. And momentum conservation means before collision and after collision. So P equal to P prime. And kinetic energy conservation means we will write it later. Okay, the total momentum before the collision and total momentum after collision is equal. Okay, that's called momentum conservation. So before the collision is m1 v1 plus m2 v2. That's the total momentum before the collision. And the total momentum after the collision is m1 v1 prime plus m2 v2 prime. And v1 v2 is known, is given. Okay, but v1 prime is v2 prime. That's we don't know. Okay, and we want to solve the velocity of these two objects after the collision. So we have to solve the v1 prime and v2 prime. Okay, and v1 prime, v2 prime, you have one equation and two unknowns, one equation. So it's not solvable. So we need another condition. Okay, another equation, and another equation comes from the kinetic energy conservation. So kinetic energy conservation is K equal to K prime. Okay, so the total kinetic energy before the collision is 1/2 m1 v1. Okay, it's square plus 1/2 m2 v2 square. Okay, and equal to 1/2 m1 v1 prime square plus 1/2 m2 v2 prime square. Okay, so we got the two equations and two unknowns. Yeah, it should be solvable, and we will only have one solution. Okay, because two independent equation and two unknowns. So we can get only one solution. Yeah, but solve the v1 prime, v2 prime. Yeah, it needs a lot of algebra work, and I will show some detail for you. Okay, so let's solve this equation. Okay, so and next step we have to do do a lot of arrangement of this. So, okay, first of all, I will do, okay, in this second equation, all have 1/2, so you can divide it by this term first. Okay, and then we will do arrangement. Okay, so much better. Okay, let's try. Hmm, Let me see, which one is better? Hmm, Okay. Okay, so let's do it. Okay, so M1 is V1 minus V1 prime. Okay, and then what should we do? Okay, so it's equal to M2 V2 prime minus V2. Okay, let's do arrangement first equation. And the second equation, what should we do? Okay, so we have M1 V1 square minus V1 prime square. And okay, equal to M2 then V2 prime square minus V2 square. Okay, we first will arrange this. Okay, stop, check yourself, check yourself. Yeah, maybe I skip some small steps, but Yeah, of course. I don't want to make the video too long. Okay. So, okay, we do the further because, and then we have the square difference. Square difference here. V1 square minus V1 prime square. V2 prime square minus V2 square. So when you have the square difference, do you remember that if you have A square minus B square and it's tell you mathematics teacher will tell you, okay, we'll get A plus B times A minus B. Okay, so we'll use this square difference formula, okay, to do a little arrangement on the second equation. Okay, so, okay, first one, just keep it, don't do anything. Okay, so this M1 V1 plus V1 1 times V1 minus V1 prime equal to N2 V2 prime plus V2 V2 prime minus V2. Right, okay. And so, okay, we say, give a number of this equation. So, how do we get, I think I should also label the equation. What should we label? And just label it. Okay, so it's called 1, it's called 2. Okay, and that's the 1 divided by 2, and let's divide this 1 divided by 2. This divide is 2 equation. 1 divided by 2. So we have the equal sign. Okay, the equal sign is here. It's M1 V1 minus V1 prime. It's M2 V2 prime minus V2. It's M1 V1 plus V1 prime. V1 minus V1 prime. M2 V2 prime plus V2 and V2 prime minus V2. And we will finally get this. Okay, this can cancel out, cancel out, cancel out, cancel out, cancel, 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 cancel. Is this correct? Okay. So we will 1 divided by 2 will reach this conclusion. Is V1 plus V1 prime equal to V2 prime plus V2. Okay, and we will arrange this. Okay, we will arrange this equation. We will arrange this and get a very important feature equation of the 1D collision. Another feature equation for the 1D collision. So I just do the arrangement. So we will get V1 minus V2 equal to V2 prime minus V1 prime. This is also the feature equation of the 1D collision. Okay, and the left-hand side is the velocity, relative velocity. It's relative velocity before collision, and the right-hand side is also a relative velocity after collision. After collision. Okay, it's before and after the relative velocity before the collision is left hand side and right hand side is relative velocity after the collision. But the relative velocity, the relative index is different, so be careful. Okay, because the left hand side is 1 minus 2 and right hand side is 2 minus 1. Yeah, be careful. The both sides are all relative velocity. Left hand side before the collision and right hand side after the collision. And but its relative index is different. Okay, just be careful. Left hand side 1 minus 2 and right hand side 2 minus 1. And you cannot reverse it. Don't reverse it. Okay. Okay, so we get the feature equation of the for 1D elastic collision. I think we can solve the velocity after V1 prime and V2 prime out. Okay, because right now we haven't solved the V1 prime, V2 prime. Okay, so we can use the feature equation. Okay, we use the feature equation. Okay, let's use the V2 prime first. Okay, from this feature equation, we will have V2 prime is equal to V1 minus V2 plus V1 prime. Okay, so we can take this into where take this equation. Okay, take substitute v2 prime in one. Okay, and put this is in one. Substitute v2 prime in one. Okay, so okay, what's the okay? I have to write. I have to. Yeah, can I copy this? Yeah, that's right. Ah, ah, um, okay, let me write this. Copy. Ah, ah. Oh, yeah. I need to move this to. Ah, yeah, sorry, I'm kind of. Yeah, how to move this? How to move this? Sorry. Hold on. Okay. Okay. So substitute V2 prime in one. So, and we substitute a substitution. So M1 V1 minus V1 prime equal to M2. Okay. So V1 minus V2 plus V1 prime. Okay. And so we have to get the V1 prime out because this is only the unknowns we have in this equation because M1, M2 is given, V1 is given, V2 is given, so only the unknown is V1 prime. Okay, so okay, let's just yeah, it's algebra work. But you have be very patient and be very careful because very easy to do the wrong calculation. That's really true. Yeah. And okay, let's see. So we will have m1 plus m2 v1 prime equal to, okay, let's see, m1 v1. So let's be careful. M1 is, I move this M1 V1 prime to the right hand side, and so I have to minus M2 plus M2 V2. Okay, so I think we'll reach the conclusion in the most textbook. M1 plus M2, M1 V1, and it's plus or minus. Mm, sorry, this is wrong. 2 M1 plus M2. So M2 V2. Okay. So let me check if the answer is right. I have to check. Because if this is wrong, V2 prime is wrong. Yeah. Yeah. Why yeah, yeah, I missed a term. Did I miss a term here? Yeah, I missed this should be a 2 here. Okay, is that what I missed here? Hmm. I missed a term here. What is this? What is a tree? What is oh, oh? Let's see. There's right substitution here. V2 plus B1. Ah. Uh, ah, like I say, mm, okay, minus V2 here. So we'll have the minus M2 V2. So, and then I'll have, mm, so, okay. So again, so here is plus 2, M2. So we will finally has the 2 here. Okay, so pretty easy to run calculation. Okay, so that's a V1 prime. Okay, so and what's a V2 prime? Okay, so V2 prime, just we can use the feature equation. V1 minus V2 plus V1 prime is equal to V2 prime. So V2 prime equal to V1 minus V2. V1 minus V2 plus V1 prime equal to V1 minus V2 plus M1 plus M2, M1 minus M2, V1 plus 2M2, M1 plus M2, V2. Okay, and I think it's much easier to solve the V2 prime now. Okay, so let's see. We have 1 plus M1 plus M2, M1 minus M2. So it's V1. Okay, and plus, let's say 1 plus M2, 2M2 minus 1. Ah, sorry, not here. Not here. Minus 1. V2. Okay, um, and let's do some arrangement here. Okay, also do some algebra work in this bracket. So what will we have? Okay, M1 plus M2. So it will have M1 plus M2, 2M1, V1 plus. So it's M1 plus M2. So it's 2M2 minus M1 minus M2. So what's the answer? It's M2 minus M1. And okay, okay, 1, V2. Okay, so we will finally get the v1 prime, v2 prime. So the velocity after the collision. So this one and this one. Okay, and you see the formula. Yeah, it's very hard to remember in my opinion. It's very hard to remember, and you can, because this format is so similar, so it's very easy to do. The memory will mess it up. It's so similar. But actually, in a later when I solve the when I try to solve the collision elastic collision problem, I rarely use this formula. And this is just demonstration, just show you what's the formula in the textbook, where this formula comes from. Yeah, where the formula in textbook comes from. And actually, we just use these two concepts. Yeah, what's two concepts? Okay, we just use these two concepts to solve the velocity after the collision. Yeah, it's momentum conservation and kinetic energy conservation. Okay, and then it's just all algebra work. Okay, and during the derivation, we also get the feature equation of 1D elastic collision. Okay, this is very important. This is very important because in the later I will use this a lot to solve the collision problem because I just write here. Okay, because we have momentum conservation, okay, equation for momentum conservation and kinetic energy conservation, right? Kinetic energy conservation, and we also have this feature equation. But so no matter what kind of no matter any collision problem for any collision problem, momentum conservation is must be used. Okay, and you can combine with the kinetic energy conservation to solve problem, and you also can combine with the feature equation of 1D collision to solve problem. And this two is much easy to use. Okay, easy to use. Okay, because when you look at this feature equation, let's say it's first order. Okay, this is the first order equation. First order equation. And momentum conservation is also first order. Okay, since these two equation, momentum conservation and this feature equation, they are all first order, so they are much easier to solve. Okay, you also can combine momentum conservation and kinetic energy conservation to solve the problem. The problem in the kinetic energy conservation equation, this is second order because you have a v squared, so it's second order. And second order, you have more algebra work, and that will make your computation much more challenging. Okay, so for the 1D elastic collision problem, I recommend the momentum conservation and this feature relative velocity equation. Use these two equations to solve the 1D collision problem. That will make life easier. Okay, and if you want to memorize this, if you can memorize this, okay, you can do it. Okay, I'm not limited. I'm not. Well, I don't have any restriction for the solving the problem. If you can memorize it too, of course, of course, you can use them. But I'm not a fan of all these two equations. I'm not a fan for these two equations. Okay. I like the momentum conservation and this relative velocity feature equation for the 1D elastic collision. This is I like to use. Okay, so next video I will just discuss this result on the 1D collision result a little bit. Okay, and yeah, discuss a little bit in the next two videos to discuss something in the conclusion of elastic collision, and then we'll show you one or two examples for 1D elastic collision. Okay, here's I'll start a video here and see you in the next video. Bye bye. Bye bye bye. And looks like these two people are fighting each other.